Hello everyone, welcome to the 6th video lecture of class 8 science. So we are dealing with our second unit, that is forces and pressure. In this video lecture we will be learning about increasing and decreasing the pressure and pressure exerted by air. So what are the factors? We have studied about the pressure, right? In the previous video we have studied about the pressure. So what are the factors on which the effect of pressure depends? Previously we have studied already pressure depends upon thrust and area of contact. So it actually depends upon these two quantities. That means if there is any change in thrust or if there is any change in area of contact, there will be change in the value of pressure. That is what it means. Okay, so how exactly the relationship is? What happens the thrust is in if the thrust is increased or if thrust is decreased, or what happens if the area of contact is increased or area of contact is decreased. So that is what we are going to see exactly in this video. So how to increase the pressure? The effect of pressure can be increased by increasing the thrust. So we remember the formula is P is equal to force or thrust divided by area. That means thrust is in the numerator and area of contact is in the denominator. So if the numerator increases, the value will be increasing. If the denominator decreases, then also the value will increase. The same thing. Increase thrust pressure can be increased by increasing the thrust or by decreasing the area of the surface of the body experiencing the thrust. That means the area of contact. Okay. So how can we increase? Two things. Either by increasing the thrust or by decreasing the area of contact. For example, we all have seen an axe, nail, knife, injection needle, bullet, etc. All these are having sharp, fine edges so as to exert a larger pressure on smaller area of the body in order to get the maximum effect from them. You can see in this two figure also. Yeah, here you can see one object is there which is not actually sharp at the edge. Other thing is here the needle, down one. So we know that obviously when we try to hit them, the first object will not go easily. How much ever you put force, apply the thrust or the force, it will not go so much easily into the wall. But in the case of nail or kind of a needle, if you try to push, a small push or the small thrust or the small force is enough to push it inside, right? So that is what we say. If the area of contact means the sharpness, if it is more sharp, then it will go easily, right? That we have observed it. So if the area of contact is small, the pressure will be more. If the area of contact is less, then the pressure is more. Okay, so that was about one of the example. Then how actually we decrease the pressure? Just opposite of how we increased it. So we can, the effect of pressure can be decreased by decreasing the thrust or by increasing the area of the surface of the body experiencing the thrust. Okay, example. So it is very difficult to walk on sand, right? But camels can walk easily on it because they have large padded feet which increase the area of contact with the sandy ground. This reduces the pressure and enables them to walk easily on the sand. So we know that by increasing the area of contact, we can decrease the pressure, right? You can see this is The feet of camel, can see they have a large padded feet. It will be very large, very broad compared to ours. So what happens? Area of contact is more. So what happens? The pressure will be less. So it becomes very easy for camels to walk on sand. That's why we see more of camels in deserts, right? So that was one example. Another example is more number of wheels are provided for a heavy goods carrier for decreasing the pressure, thereby increasing the area of contact on the road. Okay, so we have seen there will be many large vehicles which actually carry a huge um, goods, right? A good carrying truck, we can see they'll be having very high number of, I mean, very high amount of heavy goods. So that's why thrust will be more. That means they the weight will be very much high. So what happens? They will be uh, having very much thrust, the force towards the earth. Thrust is nothing but the force towards the earth will be very much high. So what they do, they keep more number of wheels so that the contact area becomes more. Number of wheels are increased. That means what? Area of contact will be increased. So what happens? When the area of contact increases, the pressure will decrease, right? So that's why more number of wheels are given, provided. The other one is broader straps are provided on the backpack for giving a lower pressure on the shoulders by providing a larger area of contact with the shoulder. So we have seen our school bags will be having two straps, right? So those straps will be broader. They'll not be just like a thread. No, right? None of your bags will be like having a thread. So it will be a broad strap. So this is what I'm talking about, two straps which will be wearing. Okay, those two straps will be very much broad, not like a thin wire or thin thread or thin rope. It will be broad strap. So why it is given? When the broad strap is given, what happens? The area of contact will be more, so that it will exert a less pressure on your body. Therefore you will not feel much pain. In case, instead of those broad strap, if you have a rope or a thread kind of a thing, narrow strap, what happens? You will feel, you can see the reddish thing happening in your shoulders, right? A reddish thing coming on your shoulder, a blood clot kind of a thing will be seen. That means what? More pressure will be experienced by you, because area of contact will be reduced, pressure will increase, so you will feel the pain. So that should not happen. There should not be any pain, or you should not experience any such kind of pain. That's why what manufacturer will do, the manufacturer will broaden the straps of the backpack or your school bags, so that you should not feel any kind of pressure or pain. So these were about decreasing and increasing the pressure. So the next thing which we are going to see is pressure exerted by air. Okay. We know very well that air fills the space around us. Whatever is present, whatever is surrounded by you, most of it is nothing but air, right? Yeah. The envelope of air is called as this envelope, which you are surrounded by. This envelope is nothing but the atmosphere. This is what we call as atmosphere, right? It extends up to many kilometers above the surface of earth. So we call the surface of earth as atmosphere up to several kilometers. After that we call the surface as with so many other names. You have seen so many other spheres come, troposphere, stratosphere, so many other spheres come into picture. So up to several kilometers, the Earth's surface is called as atmosphere. All objects on the surface of Earth experience thrust or force due to this atmosphere. Okay, so you can see in the picture, the Earth is there, and you can see one more ring, and that is nothing but the atmosphere. So this air or the atmosphere will apply some force. That's what they say. All objects on the surface of Earth experience thrust or force by the atmosphere. Right? So this air which is present around us will be always applying some force on us or any object on the surface of this earth. That is what is shown in the picture. So that the amount of force or weight of the atmospheric air that acts downward on unit surface area of the surface of earth is known as atmospheric pressure. So we said that this atmosphere will be applying some force, some amount of force on the surface of earth. This force per unit area, per unit surface area of earth is called as atmospheric pressure. So normally we know that pressure is nothing but force or the thrust per unit area, unit surface area. In this case the force is given by the atmosphere. So we say that this force, this pressure is due to the atmospheric force. That's why the pressure is also called as atmospheric pressure. It is defined as the amount of force or weight of the atmospheric air that acts downwards on unit surface area or per unit area of the surface of earth is known as atmospheric pressure. Okay, so it is very well clear from the picture. There is an atmosphere which is represented with some whitish blue color, and it tries to push or push the objects which are present on the surface of earth, or ultimately it is trying to apply some force on the surface of earth. So that force divided by unit area of the earth's surface will give us the value of atmospheric pressure. Okay, so more about atmospheric pressure. The amount of force or weight, the same thing, the definition of atmospheric pressure. And then atmospheric pressure decreases with altitudes from the surface of earth. So from the sea level, if you're going to any mountains or peaks or hills, the atmospheric pressure goes on decreasing. So usually the surface of earth, the normal surface of earth is taken as the sea level. Okay, if you're going above from the sea level, that is if you're climbing any mountain or hill or a peak, that means you are going above from the surface of earth, high altitudes we say, right? If you're moving towards high altitudes, the atmospheric pressure will go on decrease. With the altitude, the atmospheric pressure will decrease. Okay, it can be measured using the device called barometer. The atmospheric pressure can be measured using a device named barometer, and this barometer was invented by Torricelli. Okay, so now we'll be studying about the barometer. Atmospheric pressure can be measured by the height of the mercury column in a barometer. So what exactly the barometer contains? It contains mercury. Using mercury, we are calculating the atmospheric pressure in the given barometer. Okay, how exactly it looks? So this is how the barometer looks like. A simple barometer looks like. So it contains mainly a beaker containing mercury. This is a beaker, glass beaker, or a beaker which contains mercury, and this is a glass tube which will be empty initially. So what exactly we do, we go to a place where exactly we need to calculate the atmospheric pressure. So first we'll be going to the sea level. From there we will start to calculate the atmospheric pressure. So this beaker will be kept, the beaker containing mercury will be kept at the sea level. Then what we do, we take a glass tube, we will inwardly place that glass tube into this beaker like it is shown here. So what happens, a common sense, we know that the mercury, an empty glass tube will be kept. So what happens, there will be a raise in the mercury inside the glass tube. What happens when we put the glass tube inside this beaker in an inverted position, the mercury will start to raise in it like this. So it will up to reach up to certain level and stop there, right? So if you tried with the water also, sometimes you can see, or oil also, you can see there will be a rise in the any kind of a liquid which you are placing into that beaker. Okay, so this is the common simple principle or simple thing regarding the barometer. The height of the mercury column denotes the atmospheric pressure at the place at a given time in millimeter of mercury. So how much it is raising, to up what height the mercury is raising, that will give us the value of atmospheric pressure at that place. We talked about the sea level, so that will be the pressure or atmospheric pressure at the sea level at that time. This pressure may change due to the atmospheric condition. So at that time we are talking about the atmospheric pressure which will be given by the height of the mercury, or we call it as mercury column. The height of mercury column denotes the atmospheric pressure at that place, at that time, in terms of how we say, how in what terms or what units we say, in millimeter of mercury. The atmospheric pressure is so much millimeter of mercury. Okay, so this was the initial barometer concept. Even if you tilt the tube at various angle, you will see that the level of mercury will not vary. At this condition, if you try to move the thing, the whole setup into various angle, you will see that the mercury level will not change. At the sea level, the height of the mercury column will be around 76 centimeter or 760 millimeter or 29.92 inches. But we say it in terms of millimeters, right? So atmospheric pressure at the sea level is usually found as 760 millimeter. So the atmospheric pressure will be 760 millimeter of mercury. The pressure exerted by this mercury column is considered as the pressure of magnitude 1 atmospheric, 1 atmosphere, or 1 atm pressure. So this much pressure is called as 1 atm of pressure or 1 atmosphere pressure. So 1 atmospheric pressure is equal to 1 atm. It's kind of a short form, atm. 1 atm, which is equal to pressure exerted by the atmosphere when mercury rises to a height of 76 centimeter in the barometer. When there will be a formation of 76 centimeter mercury column. That means if the mercury in the test glass tube rises up to 76 centimeter, this barometer, then we say that there the atmospheric pressure is 1 atm, and it was calculated as 1.01 into 10 to the power 5. It is 10 to the power 5, okay, not 105, it is 10 to the power 5. 10 to the power 5, 10 raised to 5. Again, this looks, so this is a correction, please make it, so here it is wrong. It is 1.01 into 10 to the power 5 Newton per meter square or Pascal. Newton per meter square is also called as pascals. So the SI unit is 1 atm, which is equal to 1 lakh pascals approximately. It is 1.01 into 10 to the power 5, but approximately you can say it as 1 into 10 to the power 5, nothing but 1 lakh pascals. So SI unit of atmospheric pressure is oh sorry, I said it as SI unit as 1 atm, sorry, it is SI system. In terms of SI system, if we talk, that is 1 atm will be equal to 1 lakh pascals, and the unit SI unit is Newton per meter square, that is nothing but pascals. So atm is not the SI unit, Pascal is the SI unit. Okay, Pascal is the SI unit of pressure, but in terms of atm also we talk, that is one, the conversion from 1 atm to Pascal is given as 1 atm is equal to 1.01 into 10 to the power 5 meter square Newton per meter square, or 1 lakh Newton per meter square or 1 lakh pascals. So this was about pressure exerted by air. Okay. So when we talk about pressure exerted by air, we talked about atmospheric pressure and how actually we define the atmospheric pressure, what is an atmosphere, and then we talked about a device which is used to, or an instrument which is used to measure the atmospheric pressure, that is the barometer. The simple concept of barometer, which uses mercury to measure the atmospheric pressure, was also discussed, where in case of barometer, the height of the mercury column will tell us the value of atmospheric pressure at that given place at that given time. So that completed the pressure exerted by the air. Previous to that, we studied increasing and decreasing the pressure. So we know that pressure depends upon thrust and area of contact. So once the relation between thrust and area of contact with pressure is P is equal to F by A, where F is thrust or force divided by area of contact, will give us the value of pressure. So as we increase the amount of thrust, the pressure will increase. As we decrease the area of contact, the pressure will increase. On the other hand, for decreasing the pressure, we have to either decrease the thrust or increase the area of contact, and we have seen some of the example for increasing where increasing the pressure and decreasing the pressure also, so from our day-to-day life. So this completed our today's video lecture. So in the next class we'll be seeing the pressure exerted by the fluids. Thank you.